Now here we're given, we wanted to write the equation of the line that goes through this point and is parallel to this line. Remember, parallel lines have the same slope. So if we start with that line and solve it for y, so we have negative 2y would be a negative 5x when we subtracted 5x from each side, plus 8. And then y would equal 5 halves x minus 4 when we divide everything by negative 2. Now we know the slope of our line is 5 halves, and our line y minus the y value equals the slope times x minus the x value of negative 3. So y minus 2 equals 5 halves x. This will be plus 15 halves. Y will equal 5 halves x. Remember, our 2 we're adding to each side would be 4 halves, so this is plus 19 halves. That would be the equation of our parallel line. Now we want to write the equation of the line that goes through negative 3, 2. Now we want it perpendicular. So we already know that the slope of this line was 5 halves. It's the same line we had before. So the perpendicular slope will be negative 2/5, the negative reciprocal. Now we can have y minus 2 equals a negative 2/5 times x minus a negative 3, so plus 3. Y minus 2 will equal negative 2/5 x minus 6/5. When we add the 2 to both sides, that would be 10/5 that would add to each side. So negative 2/5 x, 10/5, and negative 6/5 will be plus 4/5. And that would be the equation of the perpendicular line. In the form of a line, we're working a lot with y equals mx plus b, but the general form is ax plus by equals c. A, b, and c are real numbers, and both a and b cannot both be 0, because otherwise these were both at 0, we'd have 0 equals c. That would not work. So the general form of a line is ax plus by equals c. A, b, and c are real numbers. A and b are not both 0. The point slope form, y minus y1 equals m times x minus x1, where m is a slope and y1 is on a point on the line. Slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept, so the y-intercept being point 0b, so the b is the y value. Vertical line, x equals a. Horizontal line, y equals b. The average rate of change. The average rate of change of a function with respect to x over the interval from x equals a to x equals b, where a is less than b. So we're talking about having, here's our axes, we're talking about having a nonlinear function like this. And this would be our point. X would equal a here, and x would equal b here. And then we want the average rate of change, or basically, the average rate of change is a change in the f of x values, so the y values for both these points, over the change in the x values. So essentially we're looking at just finding the slope of the line that connects these 2 points. That's the average rate of change. Generalizing that average rate of change, we get what's called the difference quotient, and this becomes very important for those of you going on to calculus. So basically our 2 points we have are x on something with y and x plus h. So that's the one that's farther. Now, so the y value is f of x here, and the y value for at x plus h is f of x plus h. So that's what we're doing. We have the difference quotient here. So here's the farther y value minus the first y value over the new x value minus the first x value. Well, it turns out that the x canceled out and it just in h, and so we simplify to f of x plus h minus f of x. Let's look at what happens with that difference quotient. We have right here the function of x squared plus 1. That's the graph of change, and we want the average rate of change between this point and this point. And we've just called them x and x plus h. So we use the difference quotient, f of x plus h. So that means in place of this x, we're going to put an x plus h. So x plus h squared plus 1. That's my f of x plus h minus the regular x squared plus 1 all over h. And remember, when we square a binomial, it's x squared plus, we'd multiply x times h and x times h twice, so 2xh plus h squared minus 1, or plus 1, sorry. Removing these parentheses, we'll get minus x squared minus 1 all over h. Now, combining like terms, here's an x squared, here's a negative x squared. They're gone. We'll have a 2xh plus an h squared, then plus 1 minus 1 all over h. Since h is a factor of the numerator, in other words, we could factor it out, h times 2x plus h would be the numerator, divided by h. Now these can cancel out, and my difference quotient is x plus h, or 2x plus h.